Right. Excellent. Now that we know what a portfolio of financial securities is, let's apply what we learned in the previous lecture in Python. To do that, we will work with a hypothetical portfolio composed of Procter & Gamble, Microsoft, Ford, and General Electric stocks. So, the code that you see here starts in the following way. In the beginning, we use the first few cells to load the data from Yahoo Finance. It is done in the same way as we showed you a few lectures ago. Once we've loaded the data, we are ready to perform an ordinary check. The result shows us the data is clean, complete, and well organized, containing the same amount of observations for each of the 4 securities. The beginning and ending values look reasonable too. Just to be certain, let's do a quick check of Yahoo's website. Okay, as you can see, P&G's latest closing price corresponds to the value we see here. Excellent. Our next task will be to create a line chart, which will allow us to understand how these securities perform throughout the time frame under consideration. This formula helps us normalize the data to 100. The iLoc indexer with 0 between the brackets will extract the data from the first column of the table. Yep, true. We just obtained the first row of the entire data. So, the formula will first divide the adjusted price value of a certain date by the very first number, and then we'll multiply the obtained quotient by 100. We say this calculation will normalize our data to 100. This is a mathematical trick. The first row divided by itself will always produce 1. Multiplied by 100 will give 100. That's why in the graph, all the lines initiate from the vertical axis at the point corresponding to the value of 100. The idea behind this operation is to compare the behavior of the 4 different stocks as if they were all starting from the same value, 100. If we don't do this, we will see the adjusted closing prices of all companies plotted directly, and we will not have a good landmark. Normalization tackles this issue and is a practice every financier applies in his work. Before discussing the lines on the graph, please let me make a quick Python observation. In the previous lecture, we explained how LOC and iLoc work. Well, to apply LOC, we'll have to indicate the precise label corresponding to the first row. Why? Because the dates are labels, and that's the requirement to use LOC. Alternatively, to use iLoc, we need to leave a simple indication of the position of interest, 0, given we are interested in the first row. Both approaches lead to the same outcome. There are advantages to using one instead of the other in different data sets. Here, iLoc 0 is shorter to type and is more intuitive to use, indicating clearly that we will refer to the closing prices of the first registered trading day. Okay, end of note. So, to interpret the graph, we must say Microsoft is a fair winner. It beats the other stocks regarding stock price performance. From 1995 until the end of 2007, the moment of the global financial crisis, General Electric performed better than Procter & Gamble, but apparently, it could not sustain the tumble. Procter & Gamble shares have cost more ever since. Finally, Ford enjoyed a short-time lead over P&G, but that was all. Their adjusted close price has since remained relatively low. Good. In theory, if past performance is indicative of expected future performance, this type of analysis could help you understand which stocks performed better historically. Okay. The next task on our agenda will be to calculate the simple return of these stocks and create a new table with them. Why simple returns? Because it is the preferred approach when we investigate a few stocks over the same time period. Remember? Do you remember how you can create a NumPy array? This is a perfect situation where we can apply this technique. Assume equal weights of 0.25 for all 4 stocks, because a portfolio's weights must always sum up to 1. We are working with a single portfolio. Okay, so what we still need to do is calculate the product of the weight of each stock by its return, right? This will be equivalent to a matrix multiplication in mathematics. We will need NumPy's dot method. It allows us to calculate vector or matrix products straight away. Moreover, in Pythonic, the one or multidimensional array we obtained is referred to as the dot product between the variables. By doing this, we'll multiply each stock's weight and its respective return. What are we waiting for? Let's apply the dot method to the returns we obtained and the portfolio weights we created. Great! Or not so great, actually. Didn't we expect to see a number here? A number that tells us what the entire portfolio return will be? So why did we get an entire array? Because we multiplied each value from the returns table with the weights quoted. We forgot to estimate the average return of each stock's price first. Let's assign the average yearly returns of the 4 stocks to the variable annual returns. Okay, these are the 4 stocks' annual returns. Let's try estimating the dot product now. Good, we obtained a single number. Awesome! Let's store this as a beautiful percentage value containing only 3 digits after the decimal point. This line of code lets us do that. Bingo! 14% approximately. To compare this combination with the performance of another portfolio, we must assign new weights for each stock. We already know the mechanics, and we have calculated the annual returns, so we need to go through the same steps to obtain the return of the second portfolio. I will set the weights like the ones we mentioned earlier, 0.4, 0.4, 0.15, and 0.05. We take the dot product of the annual returns and the second set of weights, and then print it out together with the other portfolio return value. Presented this way, one above the other, it is easy to see which portfolio had a greater return, right? Well done! Feel free to apply to practice what you learned in this lesson by solving the exercise task attached to it. Good luck, and thanks for watching.